Yep. Hi, everyone. I'm Rishabh. I'm a PhD student in the RISE lab. And I'm going to introduce the technology that we're going to demonstrate to you in the tutorial, which is how to train an XGBoost model collaboratively. Specifically, we'll demonstrate federated version of XGBoost. Okay. So a lot of you are probably familiar with what XGBoost is already. But in case you aren't, it's a very popular system for training ensembles of gradient-boosted decision trees. And these are just some statistics by which you can gauge how popular this model is. 17,000 stars on GitHub, 4,000 projects that use XGBoost themselves. And beyond just these stats, it's been very popular in Kaggle competitions. It's always amongst the top models that are used by the winning entries. So just to give you a primer on what the model looks like. So what you train using XGBoost is an ensemble of decision trees. So here, there are two decision trees, and the task is perhaps to figure out whether a sample or whether a person enjoys video games. So in this particular case, you have two trees. The first tree checks whether the given sample, the age of the sample, the very age of the feature, and the second tree checks whether the sample uses, or whether the person uses computers daily. So in this case, age and uses computer daily are the features. And in a decision tree, at each node, we have a feature that classifies the input one of two ways, left or right. And the task for training is to figure out what the tree looks like, what these features at each node will be, and what the split values for these features should be at each node. So before I describe how to do this in a federated manner, let me take you through what local training would look like in XGBoost. And this is a very high-level example just meant to give you a quick idea of what training looks like. So suppose you have a machine that has these samples. The samples have two features, pink and blue. Now, to train a model on these samples, what the participant will do first is it'll sort the samples by the first feature, in this case, the blue feature. Once it's sorted, it'll identify what the best split is for that feature, which particular value for the feature partitions the samples best. In this case, let's say it's 5.5. It repeats the process for the second feature, sorts it, and then identifies the best split value for the second feature. Then based on these two splits across these two features, it figures out which feature splits the partition best, and in this case, it's the blue feature. So it'll add that as a node to the decision tree. It'll then partition all its samples by this chosen feature and split value into two parts, and then this process continues for each part of the partitioning, and the model gets trained. Nodes get added, splits get determined by features. So the question then is, how do we do this in a collaborative setting? How do we do this in a federated setting? So to do collaborative training, we have one of three options, like Raluca described in her talk. The first option is to use a centralized server. So in this case, we assume the existence of a trusted third party that is located somewhere, perhaps in the cloud. So what the parties can do then, what all the three parties, or all the multiple parties can do then, is send all their data to this centralized third-party server running in the cloud. And this centralized server can then train the model on the samples that is received from all the parties, as before, using the local training algorithm. The good thing is that this method of training preserves the accuracy of the model, because if you have all the data at a particular party, that's the best you can do in terms of accuracy. The problem, of course, is that now you're leaking the entire data to this single trusted third party somewhere. More than leakage, this might be infeasible in terms of network costs, because you might not be able to transfer all the data to some single third party, the data that can be in the order of terabytes. So what do you do then? The next option that you have is to do a federated training. And to train XGBoost in a federated manner, we can use the distributed training algorithm that XGBoost provides. So what happens in this case is you have an aggregator server now. This is partly trusted. We won't transfer all the data to this aggregator server. We'll only transfer statistics or some summaries of the data at each local party. So each party, instead of transferring all the data, will propose a small set of splits. So they'll sort their individual data locally, identify the best splits per feature. So they do this first for the blue feature and identify a small set of proposals for the blue feature. They do this again for the second feature, again identify a small set of proposals. And all these proposals are then sent to the aggregator. The aggregator combines all these proposals and chooses the best split across all these. And this is then used to train the decision tree. This chosen split and feature is sent back to all the parties. The parties then partition their own data based on this, and the process continues in an iterative manner. So proposals keep getting sent to the aggregator, and the aggregator constructs the decision tree. So what we get now is, instead of transferring the entire data, we are only transferring summaries, which of a fixed size. So the communication cost is very, very low. At the same time, we're not leaking the entire data to some centralized trusted third party. So we get rid of the problems that we saw in the centralized training paradigm. On the flip side, however, we are still leaking some information because the summaries are still leaking some information about the underlying data, even though they don't directly leak the entire data. At the same time, since the parties obtain the intermediate split values, in effect, they're obtaining the entire model that will be trained by the centralized aggregator. So to solve these problems, one can train a model in the coopetitive paradigm. So what we will do to make XGBoost coopetitive is to load all the data and the code that runs on these machines into hardware enclaves. So for example, SGX. And well, Raluca introduced enclaves in her talk, but essentially they're just secure regions of memory within which you can place your sensitive data in code. So now, when the aggregator trains the model is also trained within the hardware enclave. And they have the nice property that they prevent the direct leakage of data to all the machines involved in the system, which means that all the data, all the code is always encrypted. You can't see directly what the data inside the enclave is. The problem, however, is that enclaves are vulnerable to side channel attacks. So even though you can't see the data directly, you can see the memory access patterns that the code makes. So for example, in XGBoost, you can see the movement of data when a sort is taking place. You can see the shape and the size of the decision tree. You can see which node gets chosen next while constructing the tree. And we want to hide this leakage as well, because there's research that's shown that this can leak a lot of information about the underlying data. So the idea is to implement oblivious versions of all the algorithms that run on these machines. And what obliviousness does is by oblivious algorithms, what we mean is we define the algorithms to have a predetermined schedule of accesses. So no matter what your input is, the memory accesses that the algorithm makes will always be the same, irrespective of the input. And this then prevents a leakage that we saw in the federated setting. So coopetitive training using SGX, it preserves the benefits of federated training. At the same time, no information is leaked to any party in the system. This is a loose statement because, of course, you have to reveal the final model to someone, either to the aggregator or to the parties themselves. But the point is that here you can decide. You can implement policies within the enclave. Okay. So what is this tutorial going to be about? In this tutorial, we're going to preview our federated XGBoost implementation. And the aim of the tutorial is to demonstrate the workflow for Federated XGBoost. So what we'll do is we'll have you train collaboratively a model in teams. So we'll ask you to get in teams of 3 or 4 and train a model, an XGBoost model in a federated manner. And we plan to release a coopetitive version of this by the end of the year that will leverage hardware enclaves along with oblivious algorithms that we will design for XGBoost. And this is the repo. Please watch this space if you're interested. And Chester will now take you through the tutorial.